Hello friends, welcome to our channel. In the previous video, we explained how to do serialization and deserialization for a list of strings. So in this video, we look at this problem, serialize and deserialize binary tree. This problem is marked hard by leetcode. Actually, for the coding, it's not very long. You just need to grasp the main point. So I don't want to explain the process of serialization and deserialization, but let's look at some example, right? So here, example one is a very special one because you have null tree, and then the output should be something like this. And another thing is that for the first one, so basically you have a root, so you have an output given by this, but the presentation will be different, right? That's the point you want to notice. And here you can look at the function or methods requirement. So here for the serialization, we have a root. This is the binary tree, right? And then we are going to return a string. And here we are going to have data. Data is a string, so we are going to return a binary tree, right? So the problem says are the following. So the number of nodes is in between 0 and 10 to the power 4. So 0, you can look at example 2. 10 to the power 4 basically is the upper bound of the problem size. So here the value can be positive, can be 0, can be negative, but it's restricted to negative 1000 and positive 1000. So with that said, we can do the coding. So here the overall principle will be the following. So if you do serialization, you need to be able to revert and do deserialization. This is one point. Secondly, your serialization should be able to distinguish structurally different trees. So let me give you one, but here I'm going to practice recursion. So first I'm going to get a result. So after all, we're going to return a join of this result. Right, this result will give us a string list of strings. So what we want to do is that we write a function. Let's call it dfs. So we accept the root, and then we are going to return. Basically, we are going to modify this list, right? So what we are going to do? Let me first write a pass so that we know the code structure. So then we are going to call dfs root. So you can understand this guy, dfs, as a worker. It's going to modify this result. And then after we modify this result, we just return the join. Then this the desired or we designed encoding. So let me look at this one. Here, because Python is passed by reference and this result is mutable, so I don't need to use non-local keywords. So let's write a base case. If not root, so we're going to return. But for this, we need to return, we can return something like this, but it's hard to distinguish leaf nodes later. So what I want to do is this. I'm going to return a string using this none and comma. So notice this comma is important, right? So then we're going to not return. Let's see, we want to result append this one. So if in this case we just return, this is the base condition or stop condition in the recursion. And then what we do, so if it's not a null tree, so we first return the value, the string of root value. But also I want to have a comma, because later when I do deserialization, I can do separate with respect to this comma, right? In other words, I use this comma as a separator. Then what we do dfs root left. This is legitimate because we have already considered null case. If null, we're going to get something like this. Then dfs root right. So then we, that's it. So basically you can think that we are doing a pre-order traversal. We first look at the root and then left subtree and right subtree, right? In between, we did some manipulation. This is elaborated to distinguish structurally different trees. And once we have this, we can call this function. And then we do the return of this encoding or serialization, right? So now let's also finish this deserialization, and then we can do some test and help you further digest. So for this, what I'm going to do is this. First, I want to give the data. I want to do split. As I mentioned, I'm going to use this comma as separator. And then this will be a list. I'm going to call form a deck, this list. So the reason I'm using deck because I can use q, let's see, q pop left. So this is actually also O1, right? If you use list, it's not an O1 operation, right? So then once we get this, then we just return the hyperfunction of this iterable of the queue. So here the structure will be something like this. I need to write this hyperfunction, accept a iterable, and then return the root of the resulted binary tree. So now let's fill up this hyperfunction. Again, I'm going to use recursion. So first, if we have a null tree, actually the encoding will be something like this, right? Then if we do separate, and then we are going to get something, some list like this, right? So in this case, so we see if q not is null. So here, no comma. That's important because this is what we are going to do. So in this case, we are going to do q pop left. And we just need to return, or return none if you like, right? So then if it's not null, it must be a string corresponding to a root value. So then what we do is root equals q pop left. So this will be a string. I want to change it to be an integer. I want to use this one as the root value. So notice the class signature, tree node object. So let's see, we can use tree node, then the value is this guy. Let's see what's the value. Yeah, it's a positional field. So once we have this, then what we can do? We can do hyper q, because this way actually is modified. This line modified the q. This will again modify the q, and then we do this, modify again, and then we do assignment. The left will be the L, the root right will be the R. Then we return the root. So this will be our full coding for this these two methods. Now let's run some test. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes all the cases. So now let me do some comments. First is that your serialization and deserialization should be in correspondence. In other words, your deserialization depends on your serialization. And meanwhile, when you do the serialization, you need to think of deserialization. This is the one point. Another point is that you can have different ways doing the serialization, as long as you can do, you can revert back. So this is the one thing I want to emphasize. So with that said, I guess another thing I want to mention is that here again we are using recursion, and then we are going to modify some mutable objects. So this trick or this kind of way of coding can be useful in some problems. That's the second point I hope you can pay attention to. And the last point I want to emphasize is that, so this is maybe one of the problems which related to serialization and deserialization of data structures, like list, like a binary tree and or linked list. So I want to mention that this serialization and deserialization is not only can be used for persistence purpose, but also can be used for solving some problems. So, for example, you find the duplicate trees in a binary tree. So this is also very good method if you use serialization and deserialization idea. So you can, if you are interested, you can try this problem. Try problem 652. So you can use serialization to solve this problem. You can also look at our previous video. So with that said, I guess that's it for the current video. Thank you.